Hello?
Hello. Hi. Can you hear me?
Yes, I can hear you. Hi, how are you?
Great. How are you?
I'm good, thanks.
Cool. Well, just to give you a little idea how it's going to go. Obviously things are anonymous, so if I ask you a question and you don't feel comfortable answering it for whatever reason, feel free to just, tell me. But aside from that, I'm just going to ask you a couple of questions. We'll start with a little bit of, just kind of generic questions. We'll move on to some technical questions for most of the time. And then I'm going to try to wrap up right about 15 till the next hour. So we'll have about 45 minutes total.
Sure,
And if that all sounds good, let's go ahead and get started.
sure, definitely.
Cool. So just to get to know you a little bit to begin with, I was wondering if you could maybe tell me, of all the various things that you have built, what is your favorite project to have worked on? What is the project you're the most proud to have worked on, and why?
So the most favorite project I've worked on is it was in performance improvement project, and I have
Hmm.
most of my work I have done in C, C++ on Linux platform. I have worked on in other languages also, like sometime I have worked in Java and uh, very little in Python also, but mostly I have worked in C, C++. So it was I have worked mostly in system programming, so it was a project where we needed to improve the performance of the system, and it was becoming critical because of the competitive our competitors had better performance than our product, and we needed that. It was a critical feature in order to succeed in the market. So that was it was a high pressure and very critical feature for the project, and I enjoyed it most because it was I go uh, I was allowed to make decisions like what is best, what I think, how we should proceed, and I was leading that feature. I was leading a team of 9 engineers, and it was a lot of fun in terms of the kind of work we did and the amount of changes we made. Those were enormous, and because of that, everybody was little scared that whether there will be any issues when it goes to the field. But the biggest thing was that we did so much effort in that there was no issues found in the field when it went. So that was amazing, and I got a lot of recognition also because of that, and it was because of the challenges issued in that in improving performance. Regarding the technical part of that, it was mostly that we have a multi-threaded product where in Linux it's a server, and we have multiple processes, and one of the main process performs lot of activities in multiple threads. And when we went to the higher end server, we didn't get the performance as we expected because there were bottlenecks in mainly due to locks, like there were locking contention issues, because of which we were not getting the performance what was expected. So we changed the overall threading model, and we changed that how the different type of objects are referred by different threads. So mainly we defined a threading ownership model where we mentioned that these type of objects should be accessed only by these thread, and only one single thread will be the owner for one object, which means that that thread can access all the data within that object without needing a lock, because this is the only owner, and only this thread will be creating and deleting and modifying the data members in that object. So because of that ownership, we removed some of the locking, and we needed only the locks for the containers when we will put those objects in a container, or when we will delete, only that time we needed lock, but not while we are accessing any particular data members in those objects. So that was one of the major change. We did some other changes also related to how objects should be created and how those should be accessed. We added some hash maps in our code to have the faster access. So there were a lot of framework changes which I did really enjoy making those type of changes. It was really little longer answer, but that was my favorite project.
Gotcha. Yeah, it sounds like an achievement. What kind of speed ups did you get out of all that?
So we improved 30% performance in that project. So it was quite good, and we achieved the benchmark where we needed to be in order to be able to compete in the
Very
market.
cool. Cool. Great. So let's go ahead and move on to some technical problems now.
Sure,
So for these, feel free to use any language that you're comfortable with. And
sure. I will change to C++.
okay, cool. So I'm going to go ahead and give us a.
Can
I'm
I
gonna go
change
ahead
the? Do we need the chat window? Can I move it?
no, you can close anything
Yeah,
that you
yeah.
want to. The only thing we're going to use is the editor. So let's go ahead and start with a. Let's go ahead and start with a linked list problem. This is going to be called print linked list in reverse. So I'm going to give you a very simple struct, and I'm writing this like it's C, but you can use it like a C++ struct. We're going to say that each struct has an integer for data, and it just has a pointer to the next node in the list. So it's a very basic singly linked list. Your goal is going to be to write a function that accepts the head node of the list and prints its data members to the screen in reverse order. So, for example, if we had a list that went from 1 to 2 to 3 to null, your code should just print one element per line, 3, and then 2, and then 1. Any questions about that?
Uh, so what is the maximum number of entries we expect?
So let's go ahead and say that the list doesn't necessarily have a maximum size, but we'll say that for now it's reasonable. You're not going to like overflow the stack or anything.
Okay, okay. And the data is integer, which is like it can be any negative or positive numbers within the integer data range. Is that right?
Correct.
Okay. And okay, so you want me to print it in the reverse order on the screen, is that right?
Yep, one node per line.
Okay, okay, fine. Okay, I understand the problem. So there can be different approaches to it. One of the approach can be that uh, one of the approach can be that basically I traverse this this is a single link list with where I can move only forward, so which means I cannot go back. So so one approach can be that I traverse through this list and keep putting these data members in a stack, and then because the stack is last in first out, then I can simply print all the elements from the stack. That can be one of the approach. uh, that will definitely require the order and space, and it will be an order and time complexity.
Okay.
So is that fine, or do you want me to change the
Yeah,
approach or try a different approach?
that's great. Let's go ahead and get that down, and then if we need to, we can optimize from there.
Sure. Okay. So uh, the stack implementation, do you want me to use, like there is a C++ stack object in STL, standard template library. Is it fine if I use that, or do you want me to create my
No,
own data structure?
no, definitely use the built-ins.
Okay. And you mentioned like can I change this structure to a C++ object?
Yep, definitely.
Okay. So I will use this as a class node. So I will initialize it here, and then I will define some public members to access the data, which is so these are mainly constructor and getter setter functions I'm defining.
Okay.
So that's constructor. This is get data to get it, and uh, set data to set the variable. We don't need it most probably, but just to have the both the functions. Uh, okay, so those are the basic getter setters. So now we will need to the insert in this list, and so I will define an insert function.
So let's go ahead and let's just leave it. We'll pretend that that already exists. We'll just say that the list or the node class is defined, and you can just go ahead and use it as if it were fully defined.
Okay, so should I insert, in order to test it, should I define some, like, should I insert some default data in this?
I mean, so we're not actually going to run it, so it doesn't have to be fully defined. We're just going
Okay,
to, look at it and make sure that it's right.
okay, fine. So then should I define just the main function where
Yeah, let's not even, you don't even need a main. Let's just write a function called print list, and it can just
okay,
be a void function that prints it to the screen.
so this is a function which simply print reverse data or print reverse list, and it accepts a pointer to this node uh, or head. Uh, so now this function will be uh, first I will check whether the head is valid or not. If not, it will simply return. We can't print anything, list is empty. Otherwise, we will traverse through the list. So uh, I will uh, travel through it while the list is not empty. So while head next not equal to null pointer, we will traverse through this list, and I need a stack. So stack path structure I need with integer data, a stack template with integer data, which will basically store the uh, data to be printed. So uh, reversed data, and I will. So I'm moving through this uh, list. I'm traversing through this list, and I will it's head next not equal. I first we have data in the head also. Depends how we define that node. We may or may not have data in the head, but I will assume that head pointer also has data. So
Yeah, yeah.
I will.
The node you get passed is the beginning of the list, and it also has data. So
Okay.
every node in the list has data. Yeah.
Okay. So I'm checking while head is not equal to null pointer, then I insert in the reversed data dot insert. I insert head data, and then I move head to the next. Head is equal to head next. So I keep traversing through this, and at the end head will be null. And then I will come out of this while loop. Uh, so now I have all the data in my stack in the and since it has gone in uh, the first item has gone first, it will, when I will take out, the items will come out in the reverse order. So I will simply print it. So which is the function I can use. Uh, I can use iterators for this purpose. So it is basically I will define an iterator first. In C++, there are different type of iterators, or actually I can use auto variable for that because I have already. So auto iterator is equal to reversed data dot begin. This is the function which will return the initial iterator for that list, and then I will continue until iterator is not equal to reversed data dot end, which basically returns the end position where the stack is empty now, and then I'm at moving on in the iterator. So now this iterator points to each element by element, and I can simply I'm simply printing from here. So see out value at iterator, and then you mentioned that on each next line I should print, so I will do end of line. So I print it and end of line. So this function will print the overall list in reverse order.
Okay. I think this looks good. So what's the runtime complexity of this?
It is traversing through that 2 times, so it is 2n in exact, but in terms of big O notation, it is order n.
Okay. And the memory usage?
Order again, that's order n because I'm using a stack which will contain n elements, all the elements.
Okay, sounds good. Cool. So what I would like to go ahead and do now is we're going to do this exact same problem. We'll write this next version in a separate function. So this time around, we're going to add a constraint, and we're going to say maybe the list that you're getting passed is just absolutely enormous to the point where you can't duplicate it in memory. So for this next one, we're very specifically not going to care about runtime. This can be as slow as it needs to be. All I want to see for the second version is if we can get the memory usage down to constant.
Okay. So our objective is to reduce memory consumption on the and we are fine to increase the time complexity.
Yeah.
So which means the one of the method can be the brute force method, like I start from in the for loop, I start from the head and go up to the end, and I maintain the previous pointer. So when I reach to the end of the list, and I also maintain a count. So in the basically first time I'm counting all the number of elements, and I also at the same time I print the last element, and then I know that, let's say there are 1 million elements. I have printed one of them, so now I need remaining of those, so which will mean that I will now print, I will go again from the head, I will go till the end, but I will stop one before based on the count and print the 999,999th element, and then next time one less. So basically based on the count, I will keep reducing counter and will print the one less element. Although this is very unoptimized algorithm from the time complexity perspective, because it means the complexity will be n square, order of n square.
Okay.
But I will be using constant memory, which is like one previous pointer and one counter.
That sounds good. Let's go ahead and implement that.
Sure. Print again, it is reverse. And it is mainly it's time complex, or it's more in terms of without a stack. So maybe I put the method name as it's print reverse without extra space or something. I don't know what.
You can
I'm
just
not
call
coming up with a good name right
yeah.
now.
You can call it print reverse too if you want. No worries.
Okay, so then typo. So I go with the head again. First I check if head is equal to null pointer, then simply return. Now I define my does can there be elements like which do I have to define long variable, or is it within the to be safe I can define a long count?
Yeah, may as well.
Okay, so and I define its temporary previous pointer, or and depending on implementation I can avoid this also, but it's anyways constant memory. So now I move through this again with the same loop while head is not equal to null pointer. I increase the count and I increase the head pointer. So this will, when it comes out, it will give me the count of the elements, and I'm not planning to use previous. I will simply go by that. So now I know the count of all the elements. I will simply define two for loops. Uh, uh, int list I, starting from 0, I will go up to uh, while it is less than count, and I will actually be going in the inner loop. I will be traversing every time from 0th to, or here it doesn't matter. It's not an array, so I can start indexing from 1 also. Generally, I'm used to start indexing from 0 because in C, C++, that's how it is. So, uh, so I will go from there in the inner loop to till the end and print that element, and then reduce count by 1 so that next time I go 1 lesser. So which means I can go by I can define it as count. So where this is equal to count, where till where I will go, and while index is greater than 0, and now I'm going in reverse, so I will increment my list index. And then I will have another for loop for uh, proceeding it's according to that. So L underscore J for this index. So I could use better names. Right now I'm using just L underscore I and J for indexes, which is list I and list J. Ideally I should use better names which are easier to recognize. So basically, I'm going from in the outer loop. I'm going from in the reverse. First I will print the count. So it will inner loop will start from 1 up to count, and when it reaches count, or maybe I can within that I can print it. Uh, so or that's fine. I can. There are different ways. I will print it outside the loop. So which means I will go up to that count. So I will inside this. I am moving head is equal to head next. So I'm just moving the head to the next, and every time I need to reset head. So maybe I will use a temporary pointer here because I need to uh, store it, and even before this actually, because we need to reuse the head. I can replace it with next, or maybe next is not a good name. It's like we have within the head definition we had next. So maybe its temp is also not a good name. So maybe I it's the node or next node. So here again I replace next node with head, and that's what I will use to traverse. Uh, and I can move it. I need it anyways inside, so I will move it inside the first inner loop. So now uh, this after this loop, I have reached to that count, and I will simply print that element where I am right now, which is the next node data, and then it will reset it. So I'm just checking that that's done. I'm just checking I'm not making any error in the edge cases. So basically, I'm in the inner loop. I start from 1 and I go up to until I reach the outer limit, which is set by the outer
So
loop.
let's actually
And
go
then,
ahead and, so instead of, walking through that, let's just go ahead and walk through a test case. So if you could just walk me through kind of line by line from the beginning here.
sure.
Imagine that we have our test list, 1, 2, 3, and let's just go through line by line and kind of track what the value of every variable is going to be as we go along.
Sure. Uh, uh, I'm just checking to make sure I have set all the variables correctly just last time before we start the test loop. So it is going from count to 1, and next node is this. So in this case, it will not go on the edge case. On 1, it will not go ahead and it will print first one. And in the last case, it will go up to the, if it is 3 elements or whatever, it will go up to that, and it will print that. Yes, so I was making sure I have right edge cases condition. So yes, so now to start with the test case you mentioned. So first, my head will be pointing to the data where 1 is stored, which comes in this list. I check whether it is null or not. It should not be null. It has 3 elements, and then I assign this variable count, which will have 0 initially, and yes, so count has 0. Then next node points to head, which is basically it's a temporary variable because I will be changing it. So next node goes to the first, and then within this while loop, I'm checking whether it is null or not. So it is not null, so it will go inside the while loop. Count will become 1, and next node will point to the next one. So now next node has come to 2. Yes. Then again, it will go and check whether it is null or not. It is not null, so count will become 2. And next node will point to the next one, 3. Then again, it will check whether it is null or not. It's not, so count will become 3. And next node will point to null. And now it will check whether it is null or not. It is null, so it will not go inside the loop now. So I know the count now, that how many elements are there. And then we proceed to the next for loop, outer for loop. Here, this integer L underscore I will be set to 3, and the condition will be checked whether it is greater than 0 or not. It is greater than 0, so condition is true. 3 is greater than 0, so it will go inside this loop. Uh, and now again, I'm resetting next node to the head, so it points to 1. Uh, then it goes in the inside loop. This new variable L underscore J is created with value 1, and it checks whether it is not equal to 3, which is right now L underscore I's value is 3. So is it equal to 3 or not? It is not. So it will proceed inside, and next node will point to the next one. I move next node to the next one. Then now next node is pointing to 2. Then L underscore J is incremented to 2. It checks whether it is equal to 3 or not. It is not. So again, it goes inside and increments it to 3. And then again, it comes out and it checks whether it is equal to 3 or not. It is equal to 3. So I'm checking for one less here. So no, that's right, because we are on 3. Yeah, we don't need to increment anymore. So yes, we are on 3. So the loop doesn't go in, and it comes out, and the data is printed from 3. So next node data, which will print 3. And then it goes back to the outer loop. It decrements the L underscore I value, which becomes 2 now. And now again it goes, next node is reset it to head value, which is 1, pointing to 1.
I think I think we're good. So we've seen that it looks like it's got all the right conditions, so I think we're good there. So like you said, the runtime of this is n squared, but we did get the memory down to n. Or sorry, we got the memory down to O of 1, which is good. So now with the last little bit of time we have, I was wondering, do you think there's any way that we could get the runtime of this back down to n without increasing the memory usage?
Okay, so without increasing the memory usage, we want to decrease the runtime. We can we can use the stack, but that again indirectly we will be using memory, but it will be the call stack of the process, not the auxiliary memory. So it depends whether when you say not using extra memory, is it allowed to use the stack memory, call stack memory, but not any auxiliary memory like our own stack operation. Like
Um,
basically I will be using recursive solution in that case. I will be
right.
going recursively.
Yeah, so the call stacks is still going to count in memory usage.
Okay.
So we have to try to avoid that.
Yeah, so so that solution will again be using same amount of memory. So if not that, we want to use we don't want to use memory. The challenge here is once we go to the end element, we don't know the previous node. Somehow
So
it's
let me offer a small hint here, which is
sure.
that you are not required. And oh, actually, so let me change our class slightly and just make everything public within it. So there's no requirement that you have to leave the data untouched. So the nodes that are passed into the function, you are free to modify them, if that would help you.
Okay. So uh, uh, so does will uh, before I think about modification part, with traversing through them, one thing I'm thinking about is while I'm traversing through them, I can put them in a string variable. I can start basically those integers in a string, and but that will require again memory. So I guess that will also not pass the criteria. But I just want to be sure that whether that will work or not. Basically, instead of when I'm going through them, I keep printing them in a string, and I print in front of that every time. So that will be in the
Yeah,
I'm instead of printing at
right.
cout, I
That
print
would
in
also,
a string.
yeah, that would also count as memory usage.
Okay.
So let's look at it this way, right? If I asked you to print the list out in forwards order, you could do that very easily, right?
Yeah.
So could you maybe transform the list in a way that you would be able to just print straight through it?
Oh yeah. Yes. Uh, yes. That will be much easier. Yeah, definitely. So while moving through the list, we can reverse the list, and then after. So one time I go through the traverse through the list and reverse the links so that the list becomes the reverse list, and then I can print it in the straightforward. Yes, I didn't think about that, reversing the list. I was assuming, I think that I can't change the data structure, but yes, if that is allowed, if it is fine to change the data structure links, then I can reverse the list and print it that. Yes.
Yeah, let's go and get started on that.
Sure. So basically, it's in the first function print reverse list. I get the node pointer head, and I check again if head is null pointer return. Otherwise, I call a function. I create. It's not reverse. I use the reverse print. I call a function reverse list, which will reverse it and give me, and then I print it simply with the for loop. Uh, or while loop like I did earlier. I don't need count, so this will basically based on this function, it should print it. Now I will implement that function. It is returning node pointer. So again, it will check. Uh, so now I need to maintain a temporary pointer, node pointer previous. I start it with head only, and so I'm just thinking how I will be switching the pointers basically. So I with the head I will move to the next one, and I maintain the previous one, and I set the previous one next as null in the start, and then after that I will be moved going next and next. So I might need two pointers, but I have to start with. So previous I'm storing, so while head is not equal to null pointer, previous is equal to head, then head is equal to head next, and so I have moved to the next element, uh, and then I set the next of head. I'm just thinking out loud that when I'm on a particular node, uh, I want to set it's next to the next one, but before that I need to store its next value. So previous is head, and I store head is head next, and so now head next is equal to previous, but before that I should store head next, so which means I'm overdoing it right now, so I'm just trying to make sure I don't, I'm doing it properly. So I store the current value in previous pointer, and I define one more. Uh, so I first I store the current value in previous, then I move it to the next one. In like in our example 1, 2, and 3, initially my uh, head is pointing to 1, previous stores 1, head moves to next, which is 2. It's, and then I store next as the head next, which is now next is pointing to 3. But if any of those is null, I have to check for that. So uh, if head next.
Sorry, I'm actually going to go ahead and stop you there. We're kind of coming up against our end of our time here. But this is definitely the right direction. And at this point, if you have any kind of questions for me right now, I'd be glad to answer them for you.
Yeah, sorry, I could not finish it. I think I needed 5 more minutes, but yeah, we are at the end of the time. So definitely, I will really appreciate if you can provide me feedback.
Sure. So I'm gonna, kind of write up something a little bit more detailed after we hang up, but just kind of like a quick overview. I think if this was a real phone screen, I would probably recommend that we do bring you on site. I would probably say that I wasn't completely sure about it. So you did a very good job of kind of feeling out the requirements and coming up with solutions. The only problem you ran into is that it wasn't you weren't way behind, but it was a little bit slow. So I would have liked to have seen us kind of finish this one in the time that we had. And I think that you could have made it if you just maybe cut down a little bit on like boilerplate type of stuff. So for instance, like at the very beginning when you started kind of like filling out the full class definition, it's worth just asking like, do I need to implement this or can we just assume that it's there? So I think that if we just maybe gone a little bit quicker, right? Maybe spent a little bit less time on that kind of boilerplate type of stuff, it would have been a little bit of a stronger result. But all that being said, it was still a solid interview. I think it didn't get all the way through, but you got the first two solutions fine. You definitely knew where you were going with this one. You were just kind of working out the details. So I think overall good. Maybe just go a little bit quicker, and that's kind of the overview.
Sure, yeah, that's good to know. Yeah, I agree that I should have asked that whether what to assume and what to do, so to remain focused on completing it. Yeah.
Yeah, I would say like so. Most people, their problem is that they don't communicate enough, right? Like they don't tell me what they're thinking or what they're going to do. And you did a really good job of making sure you were very thorough, telling me everything. I would almost say that you have the opposite problem. Like you sometimes maybe repeated things a little bit more than you needed to. So I don't want to tell you to like communicate a lot less because it's very good that you're being thorough, but maybe just spend a little bit less time on explanations. Just a tiny bit less, I think would help you use the time that you have available better.
Sure. Yeah, that's good to know that feedback. Thank you.
Yeah, and thanks very much for your time.
Yeah, thanks for your time and feedback.
Awesome.
So definitely, I will take care of. I will note these points and will try to take care in future. Thanks a lot.
Yeah, thank you, and have a great rest of your day.
You too. Thank you.
All right, thanks. Bye.
Bye. Bye.